Beneath the stillness of the night, the desert breathes. Grains of ancient sand shimmer under a sky so vast it seems eternal. Each star burns with the quiet dignity of ages, a cosmic choir frozen in its own reflection. The air is cool, unmoving. Yet above this silence, the heavens are not still. They are alive with motion, with the invisible rhythm of a universe that never sleeps. In the black ocean of space, nothing truly stands still. Every star, every world, every drifting atom is moving, falling, orbiting, colliding. Even the galaxies, those grand cities of light, glide through the dark sea, their motion too vast to sense, too slow for the human span to comprehend. The Milky Way, our home, curls in a spiral of stars and dust, bound by gravity's ancient hand. Across the gulf, another spiral turns. Andromeda, through the naked eye, it appears only as a faint smudge above the horizon, a blur in the constellation of Cassiopeia. Yet that smudge is a colossal island of 1 trillion suns, 2.5 million light-years away. Its light left before humanity existed, before even the first spark of civilization flickered on Earth. And yet, this distant galaxy is not drifting away into the expanding universe, as most galaxies do. It is falling toward us at 110 kilometers per second. Andromeda is approaching, not across the surface of the night, but through the very fabric of space-time itself. Each second it draws closer, unseen. Each year, the distance between our galaxies shrinks by millions of kilometers. The paradox lies in that calm sky. The same stars that inspire peace conceal a slow, unstoppable catastrophe in an expanding cosmos, where galaxies recede into the void. The Milky Way and Andromeda are defying the flow. Bound together by gravity, they are locked in a silent embrace that began before the Earth was born. To the eye, the universe seems eternal and unchanging. But to the patient gaze of science, it is a place of movement, of inevitability, where even beauty carries the seed of its own undoing. Every point of light above this desert is a messenger from the past, whispering that motion is destiny. Some of those stars belong to Andromeda, already on their way home toward us. When they finally arrive, when those two immense spirals touch, the sky will no longer be what it is tonight. That meeting will not be an explosion, but a merging, an interweaving of light and gravity that will reshape the heavens. Stars will pass through stars without collision. Planets will drift into exile, and the night will glow with a brilliance Earth has never seen. The calm sky that watches back tonight already carries that future within it. The question lingers, suspended between wonder and dread. When will the Milky Way and Andromeda finally meet? And when they do, what will become of everything we know? To answer that, humanity had to measure motion across the abyss and learn to watch the future unfold. In the slow language of light and time, it began, as many revelations do, with a flicker of doubt in the data, a faint spectral whisper that the universe was not behaving as expected. In the early years of the 20th century, astronomers turned fragile instruments toward the heavens, glass lenses and metal tubes trembling under the night wind. Among them was Vesto Melvin Slipher, a quiet observer from Lowell Observatory in Arizona, who first learned to read the light of galaxies as if it were a secret language, written in color through his prism of glass and hope. Light from distant galaxies unfurled into delicate rainbows, each streak marked by spectral lines, the fingerprints of atoms. When those lines shifted toward red, it meant motion away. When they shifted toward blue, motion toward. Most galaxies, he found, were redshifted, receding at immense speed, carried by the expanding fabric of space itself. But one object broke the pattern. The faint spiral in Andromeda did not retreat, it advanced. Its spectral lines leaned blue unmistakably. The meaning was profound and unsettling. In a universe that fled from itself, one entire galaxy was moving the other way. At first, this was treated as a curiosity, a singular anomaly among billions. But it would soon become a prophecy. A decade later, Edwin Hubble would gaze through the massive Hooker telescope atop Mount Wilson and reveal that the universe extended far beyond the Milky Way. That these spirals were not clouds of stars within our galaxy, but entire galaxies of their own. Each one, except Andromeda, was receding, carried by the cosmological expansion that would later become the cornerstone of Big Bang cosmology. Andromeda, meanwhile, stood as an exception that refused to be ignored. The blue-shifted signature persisted. Its light told a story written in motion, a gravitational defiance against the outward tide of creation. Even as galaxies drifted apart with accelerating speed, the Milky Way and Andromeda were bound together by an invisible thread. Gravity, ancient and unrelenting. Their shared mass had woven them into a single cosmic system long before life emerged on Earth's shores. For generations, astronomers sought to understand how fast that pull was drawing us together. But measuring the motion of an entire galaxy across millions of light-years required instruments of exquisite precision. Andromeda's movement could not be seen with the eye. It had to be felt through the shifts in starlight, measured over decades through spectroscopy, through the rhythmic pulse of hydrogen lines. Astronomers learned to sense this slow approach, a drift of only a few hundred kilometers per second, glacial across human timescales, but cataclysmic across eons. Radio interferometry later refined these numbers, combining distant observatories across Earth into one synthetic eye, large, enough to trace the galaxy's whisper of motion through the cosmos. Still, uncertainty lingered. Was Andromeda heading straight for us, or merely glancing by, a cosmic near-miss across eternity? The answer required not just velocity, but direction, a map of movement through 3 dimensions. Something no ground-based telescope could achieve. It was only with the marriage of 2 space observatories, Gaia and Hubble, that humanity's picture became clear. Hubble's long baseline of deep optical imaging, paired with Gaia's millisecond precision in measuring stellar motion, gave astronomers what no previous generation possessed: a full 3D vector of Andromeda's journey through space. The numbers converged with stunning simplicity. Andromeda is not merely approaching, it is falling toward us, drawn by a shared center of mass that will bring both galaxies together in roughly 4.5 billion years. In that instant, a mathematical truth became a cosmic reckoning. Every photograph of the night sky, every tranquil stargaze, was suddenly revealed as a portrait of motion, of inevitability. Above us, that faint smudge of light no longer represented distance, but destiny. The universe, it seemed, had been writing this ending since its beginning. The sky we look upon tonight already contains the script of our galaxy's transformation, playing out on scales too vast for human memory to contain. And in that revelation, astronomy became not only a science of observation, but an act of prophecy. Yet even prophecy must be proven. The cosmos does not surrender its truths easily. It demands patience measured in decades and precision beyond imagination. When Hubble's final measurements were compared against Gaia's celestial map, astronomers began to see not just movement, but intention. The stars within Andromeda were not scattered in chaos. They formed a coherent drift, a grand spiral slowly curving toward the Milky Way's gravitational embrace. The calculation was hauntingly elegant. By tracing the sideways motion of just a few luminous stars, researchers could reconstruct the galaxy's path across space, its tilt, its velocity, its angle of descent. The motion was unmistakable. Andromeda was not simply approaching in our line of sight. It was falling directly toward the heart of the Milky Way, a collision course defined by the ancient balance between expansion and gravity across supercomputers. Models began to replay the dance in exquisite detail. Two spirals, vast, delicate, alive, gliding toward one another through a cosmic ocean that offers no resistance. Over billions of simulated years, the arms of Andromeda unfurl like smoke. The Milky Way's disk begins to warp, and between them, tidal bridges of starlight stretch like filaments of silk. The first touch is not an impact, but a gravitational caress, invisible, unstoppable. Every new dataset confirmed the same fate. No adjustment, no error margin could erase the trajectory. Even the small third companion, the Triangulum Galaxy, appeared poised to join the encounter, orbiting the merging pair like a witness to a celestial union. Still, the truth carried a strange duality. It was both distant and intimate, inevitable yet serene. The collision would not come in the lifetime of any star now burning in the night sky, and yet its pull could already be measured in every photon of blue light that reaches Earth. To study Andromeda was to watch the future in slow motion, to see destiny written in Doppler shifts and gravitational curves. The enormity of the realization began to reshape astronomy itself. For centuries, the heavens were thought of as a grand but static dome, a place where time stood still. Then came the revelation of expansion, the understanding that space itself grows. And now, within that expansion, humanity discovered contraction, local gravity strong enough to reverse the tide. The Milky Way and Andromeda would not drift apart with the rest of the cosmos. They would defy it, bound by a force older than time's direction. From this paradox, a new question emerged. How could such beauty and destruction coexist in one event? The future merger would erase familiar constellations, dissolve the spiral patterns that defined our galaxy, and scatter countless solar systems into exile. Yet in that same act, new stars would ignite, born from the compression of interstellar gas. The collision would not be a death, but a transformation, one structure ending so that another might begin. And still, the data that foretold this epic was gathered quietly. Beams of light split through lenses, electrons measured across sensors thinner than paper. The instruments of humanity, fragile and finite, managed to capture the movement of worlds too vast for comprehension. With every refinement, the approaching path grew clearer, sharper, undeniable. In the silence of observatories and the cold vacuum of space, the story unfolded, two galaxies, intertwined by gravity, drawing closer through the dark. Their meeting was not a question of if, but when. And that answer, 4.5 billion years, became more than a number. It became a mirror held up to existence itself, for in measuring Andromeda's fall, humanity had measured its own impermanence. The sky was no longer a symbol of eternity, but of change, a reminder that even galaxies, magnificent and vast, are mortal in their own cosmic way. And though the final collision lay far beyond the reach of human time, its shadow already touched the edge of every telescope lens, a whisper from the future, carried across the light of 1 trillion stars. Once the numbers were known, the questions only grew deeper. Knowing when the galaxies would meet was not enough. The real mystery lay in how, for generations, astronomers imagined the encounter as an act of destruction, two titanic spirals colliding like celestial storms, tearing each other apart in a blaze of ruin. Yet when the first simulations came to life on supercomputers, The images they produced defied every expectation. What appeared was not chaos, but choreography. In those digital universes, millions of stars began to move, as one, slow, graceful, deliberate. The spirals stretched, folded, and intertwined like ribbons of molten light. Vast arms of gas and dust uncoiled, drawn outward by invisible tides, creating rivers of stars that arced across the darkness. It was a vision of motion so intricate, so hauntingly precise, that it resembled a dance more than a collision. The universe, it seemed, did not favor violence. It preferred transformation. No single star, not even the brightest among them, would collide. The distances between them were simply too immense. Each would drift through the other galaxy as if passing through a ghost, their paths bending only slightly, their orbits redrawn by gravity's whisper. From that silence, new constellations would be born, unfamiliar skies, lit by the mingling of two stellar civilizations. Yet within this ballet, uncertainty remained. The simulations offered visions, not certainties. Would the sun endure? Would Earth still follow its familiar circle around it when the Milky Way's spiral arms were torn and reshaped? Some models suggested the solar system might survive, flung outward to the edges of the newborn galaxy. Others predicted exile, cast adrift into intergalactic space, carrying the ghosts of humanity into the dark between galaxies. Even the smallest gravitational misstep could decide everything. The Milky Way and Andromeda are not alone in their approach. The Triangulum Galaxy, smaller, fainter, but gravitationally bound to both, may join the dance, tugging at their trajectories, like a third participant in a cosmic waltz. Its presence could alter the rhythm, changing when and how the spirals entwine. Each simulation became a window into a different possible future. Some showed a near miss, a close approach followed by a slow spiral inward, taking billions of years to complete. Others revealed a direct head-on union that would erase the Milky Way's familiar spiral form almost immediately. In both fates, the end was the same: a single, merged galaxy, luminous and massive, its once delicate spirals smoothed into an immense elliptical glow. Astronomers named this future structure Milkomeda, a word that feels both whimsical and allegorical. In it, every star that once belonged to the Milky Way or Andromeda would orbit a common heart, a new galactic core where two supermassive black holes, each millions of times the mass of the Sun, would spiral together and merge. The union of those invisible giants would send ripples through space-time, itself gravitational waves echoing across the cosmos, a pulse that would outlast every civilization capable of hearing it. And yet, beyond all the physics, there was something ineffable about what the simulations revealed. Watching the galaxies merge was like watching time itself breathe, a slow inhalation and exhalation of creation. The boundaries between beginning and end blurred. Destruction created form. Form dissolved into new structure. The mind struggled to contain the scale of it. Hundreds of billions of stars, each with its own worlds, its own potential for life, all caught in the same gravitational web. Every light that shone in either galaxy would be moved, reshaped, or reborn. From afar, it would appear almost gentle, two luminous spirals fading into one another like clouds meeting at twilight to some. The coming merger is a story of loss, the death of the Milky Way, the erasure of the constellations that have guided life for eons. But to others, it is an act of cosmic renewal, the way the universe recycles its grandeur. In that light, the event is not an ending at all, but a passage, the birth of something new from what once was separate. And perhaps that is the deeper truth the data cannot quantify. Galaxies are not eternal. They evolve, merge, dissolve. What seems like annihilation on one scale is creation on another. The Milky Way was once born from collisions too ancient to name, and Andromeda carries her own history of consumed galaxies within her halo of stars. This coming encounter is merely the next chapter in a process as old as the cosmos itself. The mystery, then, is not destruction versus creation. It is that both are the same. The galaxies do not fight against the inevitable. They surrender to it, their light blending into unity. Like two rivers meeting at the end of a long journey, they become indistinguishable, their separate histories folding into one luminous future. In that understanding, the night sky takes on a new meaning. The faint blur of Andromeda is no longer a stranger's light. It is the reflection of our own destiny, a silent partner drifting closer with every heartbeat of the universe. And though the meeting lies billions of years beyond human reach, the knowledge of it touches something timeless, the awareness that creation itself is never still. The mystery deepens, not because it hides from us, but because it shows too much, a universe forever changing, forever becoming. And somewhere in that endless becoming, the Milky Way waits, poised to fall gently into the arms of its long-lost twin. Even in its inevitability, the coming union feels strangely intimate, as though two ancient beings, separated since the dawn of time, were slowly finding their way back to one another. Across the great ocean of intergalactic space, faint gravitational murmurs already bridge the void. Invisible threads of dark matter stretch between them, guiding their approach with a patience that only the cosmos can afford. Each moment that passes brings them infinitesimally closer, their destinies entwined in a gravitational embrace written billions of years ago. Astronomers today can trace that approach in exquisite detail. The Hubble Space Telescope has captured the subtle drift of Andromeda stars, the minuscule motion that reveals its trajectory toward us. Gaia, with its unparalleled precision, measures the proper motion of entire star clusters, translating points of light into a three-dimensional map of destiny. From these measurements emerges a slow, stately march, the Andromeda Galaxy falling toward the Milky Way at about 110 kilometers per second, a pace imperceptible to human senses, yet unstoppable across eons. On this time scale, even the universe seems to breathe slowly. In 1 billion years, Andromeda will loom larger in our night sky, transforming from a faint smudge into a sprawling arc of starlight stretching from horizon to horizon. Its spiral arms will begin to shimmer with gravitational tides, glowing brighter as newborn stars ignite from the compression of gas and dust. Nebulae will bloom like cosmic flowers, lighting the heavens in colors no human eye has yet seen. Should any form of life remain on Earth, the sky will tell a story unlike any that came before. The constellations, Orion, Cassiopeia, the Big Dipper, will twist into unrecognizable shapes as the stars themselves are displaced by the galactic tide. Andromeda's luminous disk will dominate the heavens, a celestial river merging with our own Milky Way's band of light. The night will no longer belong to one galaxy, but two to becoming one. Then, over another billion years, their cores will begin to intertwine. Great streams of stars, tidal tails, will stretch outward like luminous bridges, carrying millions of suns into vast arcs that loop through intergalactic space. To an observer far away, it would look like a slow, balletic collision frozen in time, two glowing spirals folding into a single, radiant form at their centers. The two supermassive black holes will begin a slow spiral inward, their immense gravity pulling them ever closer until they orbit each other at relativistic speeds. The energy of their merger will ripple through space-time, gravitational waves spreading outward like the sound of creation itself, detectable across billions of light-years. It will be a quiet apocalypse, unmarked by fire or ruin, but by light and symmetry and motion. When the dust settles, the galaxy that remains will no longer resemble the elegant spirals that once were. Its arms will have been smoothed into a glowing elliptical haze, filled with countless aging stars, a single vast sphere of light, suspended in the cosmic dark. The Milky Way and Andromeda will have ceased to exist as separate entities, yet neither will have truly died. Their stars, their histories, their very matter will live on, bound together in the gravity of their shared rebirth. In that silence, perhaps, lies the greatest revelation of all, that the universe does not fear its own endings. It remakes itself endlessly, sculpting beauty from collapse, harmony from chaos. The galaxy's slow collision is not a tragedy, but a continuation of the same creative force that once ignited the first stars. And so, the mystery deepens, not in the physics of their motion, nor in the timelines we calculate, but in the poetry of what it represents. The meeting of the Milky Way and Andromeda is a reflection of the cosmos itself, every ending intertwined with a beginning, every collision a step toward greater unity, billions of years from now, long after the last human eye has looked upon the night sky. A new galaxy will shine where two once stood apart. Its stars will carry within them the memory of this moment, the quiet inevitability of union, the long journey toward wholeness. In their light, the universe will continue its eternal conversation with itself, whispering through the dark, "Nothing is ever lost, only transformed." It began, as all great cosmic revelations do, with the quiet persistence of human wonder. Long before computers, before orbiting telescopes or satellites mapping the heavens, there was only a lens, a mountaintop, and a man staring into the dark. Edwin Hubble stood at the eyepiece of the Hooker telescope atop Mount Wilson in the 1920s, his breath fogging in the cold, his hands steady on the brass fittings. Above him stretched the vault of night, scattered with countless points of light, but one, a faint smudge in the constellation Andromeda, seemed to call out differently. Through the glass, it was not a star, but a collection of stars, millions, perhaps billions, too distant for the imagination to easily hold. That smudge changed everything. It revealed, for the first time, that the Milky Way was not the universe, but one island in a boundless cosmic ocean. And yet, even then, the true motion of that island across the sea remained hidden. Hubble measured its distance, but not its intent. The universe appeared to be expanding, galaxies rushing apart, light stretched into longer, redder wavelengths, a discovery that echoed through every corner of science. But somewhere among the retreating galaxies, one defied the trend. A decade earlier, Vesto Melvins, working from the Lowell Observatory in Arizona, had turned a spectrograph toward that same hazy spiral. The light that entered his prism did not stretch toward red, as nearly all others did. Instead, its lines bent toward blue, a spectral whisper that spoke of approach, not retreat. The Andromeda Galaxy was not fleeing with the rest of the cosmos. It was coming closer. At first it seemed a curiosity, an exception to a cosmic rule. But science thrives on exceptions. Over the years that followed, astronomers refined the measurement of its velocity, learning to read motion from the faintest tilt in color, the subtlest shift in a line of starlight. The story of Andromeda's journey became encoded not in the brightness of its stars, but in the delicate dance of their wavelengths. Spectroscopy became humanity's cosmic compass, a tool that could translate color into movement, light into time, A single photon, traveling for millions of years, could reveal the heartbeat of a galaxy. Through these methods, the universe began to move in human understanding. The heavens were no longer static, no longer fixed in divine stillness. They pulsed, flowed, collided, expanded. Einstein's equations had already whispered of such fluidity. Space was not a rigid stage upon which stars merely performed, but a fabric that could stretch, twist, and bend. His theory of general relativity revealed that gravity was not a force in the traditional sense, but the geometry of the universe itself, the curvature of space and time around mass and energy. In that realization lay the key to understanding Andromeda's fate. Even as the universe expanded, the gravitational bond between massive galaxies could overpower that expansion locally. The cosmic tide pulled outward, but their mutual gravity held firm. They were destined to meet. The 20th century brought clearer eyes to the sky. Photographic plates gave way to electronic detectors, first primitive photocells, then sensitive CCD arrays capable of capturing faint galaxies invisible to human sight. Observatories spread across the planet, Mauna Kea, Paranol, La Palma, each a century watching the stars from mountaintops above the clouds. The view sharpened, the data deepened. Every new telescope added another thread to the tapestry of motion, mapping not only where galaxies were, but where they were going. Then came a revolution that left the ground behind. The Hubble Space Telescope, launched into orbit in 1990, peered through the vacuum of space itself, unblinking and unobstructed. From that vantage, it measured the tiniest shifts in the positions of Andromeda's stars, refining their motion across the sky with almost unimaginable precision. Over decades of observations, astronomers built a picture not of static beauty, but of dynamic inevitability. And yet, even Hubble's clarity was not enough. To measure the faint drift of a galaxy 2.5 million light-years away required something even more extraordinary, a mission that could chart the motion of billions of stars, not just in one galaxy, but across the entire Milky Way. The European Space Agency's Gaia Observatory became that instrument. Launched in 2013, it set out to build the first three-dimensional map of our galaxy's stellar motion. Every point of light, every subtle wobble, became a coordinate in the grand equation of cosmic evolution. From Gaia's data, a team of astronomers combined decades of observations from Hubble, from from deep spectroscopic surveys, and finally traced Andromeda's full three-dimensional trajectory. For the first time, humanity could visualize not just that the galaxy was approaching, but how it would collide, the angle, the speed, the celestial choreography. The answer that emerged from those numbers was both precise and profound. In roughly 4.5 billion years, the Milky Way and Andromeda will merge, drawn together by the same gravity that once formed their stars. Their approach is not a sudden fall, but a slow spiral, a cosmic waltz, lasting billions of years. And in this realization lies a quiet human triumph. The discovery of our galaxy's distant future was not born from fear or prophecy, but from the patient pursuit of truth. It was built one photon at a time, across generations, by minds who refused to accept that the sky was still. From Hubble's lonely nights to Gaia's billion-star symphony, the story of Andromeda's approach became the story of human persistence, a reminder that even in the vastest silence, the universe will always answer if one listens long enough. The further the instruments advanced, the clearer the story became, not only of Andromeda, but of humanity itself reaching outward, decoding the faintest murmurs of creation. Each new telescope, each improved sensor, transformed the invisible into the visible. and the incomprehensible into something almost intimate in the era before satellites. Astronomers had only the trembling air between themselves and the stars. But even then, the drive to refine, to measure, to understand never faltered. Glass lenses were ground with obsessive precision, silver coatings applied by hand in darkened rooms. Observatories became temples of silence where time moved as slowly as the heavens they observed. The faint lines of spectra etched on photographic plates carried secrets older than the Earth, the signatures of hydrogen and helium, the same cosmic alphabet written across every galaxy. Then came the age of computation, no longer limited by human sight or the sensitivity of film. Astronomers turned to digital arrays and algorithms capable of seeing motion too faint for any eye. Decades of data could be layered, subtracted, and reassembled to reveal movement, the slow drift of stars, the shift of clusters, the faint breathing of galaxies over cosmic time. What had once seemed eternal and still began to ripple with life. It was not one discovery, but a chain of them, each generation of astronomers handing the next a clearer lens, a finer measure, a deeper sense of scale. The Harvard computers, meticulously cataloging spectral data in the early 20th century. The radio astronomers of the post-war years, mapping invisible hydrogen clouds between stars. The interferometers that measured parallax, so precisely they could sense a wobble smaller than the width of a human hair from light years away. Every fragment of knowledge added to the growing mosaic of Andromeda's fate. When Gaia's mission reached maturity, its revelations were more than technological. They were philosophical. It showed that the sky itself is alive with motion. Every star in the Milky Way is moving, not randomly, but as part of a vast gravitational choreography. The galaxy spins, ripples, and breathes. Spiral arms twist through time like the slow turning of a wheel. Within this grand rotation, the path of Andromeda is but one arc, yet it is an arc destined to intersect our own. The first full 3D simulation of the Andromeda Milky Way merger was rendered from these data. On powerful supercomputers, astronomers set time in motion. They watched galaxies dance and fuse, the delicate interplay of gravity sculpting luminous rivers of stars. What emerged was not the end of either galaxy, but a transformation. The final product, an elliptical giant, sometimes called Milkomeda, shimmered as a single, unified world of light. Such models, though built from equations and code, carry an emotional resonance. They remind humanity that every measurement, every data point, connects to something profoundly existential. Through the act of observing the stars, the species glimpses not only its past, but its destiny. To measure Andromeda's motion is to look forward through time itself, to witness the slow unfolding of a future no human will live to see. Yet all are part in the dim glow of control rooms and observatories. The modern astronomers who continue this legacy share the same quiet awe that Hubble once felt on his mountaintop. They know the numbers intimately, -110 kilometers per second, 2.5 million light-years, 4.5 billion years to collision. But behind those figures lies something deeper, a connection to the universe's ongoing narrative. Every photon that strikes a detector is a message sent long before humanity existed, and still, it is understood. The origin of the discovery, then, is not only scientific but human, born from a lineage of minds unwilling to accept the silence of the stars. They transformed curiosity into method, wonder into mathematics. Through them, the universe revealed its slow heartbeat, and in that rhythm, humanity heard the faint echo of its own. And so, what began as a faint blur of light in a telescope's field has become a revelation. Stretching across centuries, the realization that the sky itself is in motion, that the heavens are not eternal and unchanging, but alive. The approach of Andromeda is not merely a future event written in equations. It is a mirror of the human condition, the eternal pursuit of meaning within motion, of understanding within impermanence. Somewhere, far above the quiet hum of Earth's atmosphere, Gaia continues its endless scan, mapping the drift of 1 billion suns. Each data packet it sends home brings the cosmic story into sharper focus, a story that began with Hubble. I press to cold glass and now unfolds through digital light. Across the infinite dark, the origins of the discovery are, in truth, the origins of knowledge itself, the slow accumulation of clarity born from darkness, guided by wonder. When the first detailed simulations of the Milky Way Andromeda collision were released, they did more than display a cosmic event. They revealed a mirror. Within the silent arcs of merging galaxies, humanity saw its own reflection, fragile, transient, and deeply aware of time. The data were mathematical, impersonal, a prediction born from physics and motion, yet what it evoked in the human mind was far more intimate. For the first time, our species confronted the mortality not of a planet, a star, or a civilization, but of an entire galaxy, in the sterile glow of observatories and data centers. Astronomers found themselves whispering about beauty and death in the same breath. The realization that even the Milky Way, the luminous cradle of every human story, would one day dissolve into another form, unsettled something ancient in the collective imagination. For centuries, the galaxy had been a symbol of permanence, the silent river of stars flowing above civilizations that rose and fell beneath it. To discover that it, too, was impermanent was to strip away the last illusion of cosmic stillness. Among scientists, there were debates not about the data, which were clear, but about meaning. Some saw the coming merger as an act of destruction, a vast erasure written into the laws of gravity. Others, with quieter conviction, described it as a transformation, the death of the Milky Way. Yes, but also the birth of something grander, more unified. They spoke not of collapse, but of continuity. Two galaxies merging into one was, perhaps, just another step in the universe's endless cycle of creation. Still, the question lingered: how should such a revelation be shared with the world? To speak of the galaxy's death risked evoking fear, a fear of annihilation, of cosmic indifference. To speak of its rebirth risked sounding poetic, detached from the cold mechanics of astrophysics. Yet somewhere between these extremes lay the truth, that beauty and impermanence are woven from the same cosmic thread. It is difficult for the human mind to grasp timescales measured in billions of years. To imagine 4.5 billion years is to venture beyond empathy, beyond experience. Empires rise and fall in thousands. Species live and vanish in millions. But billions, that belongs to the deep time of the cosmos, a realm where meaning dissolves into scale. Still, even in that immensity, humans seek narrative, longing to find themselves in the unfolding of galaxies. There is a subtle tragedy in that longing, not because it is futile, but because it is beautiful. The desire to belong in a universe that will one day forget us is, perhaps, the most human act of all. And so, when scientists describe Andromeda's approach, they often speak not just of motion and mass, but of wonder. They show the simulated images, spirals colliding, stars scattering, black holes merging, and watch as silence fills the room. It is the kind of silence that follows awe, not despair. The collision will not bring fire or ruin to our world. The vast distances between stars mean that, even as galaxies merge, Few, if any, stars will collide directly. If the sun still burns, then it will drift gently into a new orbit amid a reshaped sea of stars. From the surface of whatever world may still exist, the sky will blaze with light, vast ribbons of color, entire constellations smeared into glowing arcs. It will be the most spectacular dawn in the history of the universe. But no eyes may remain to see it. This realization that the universe continues, with or without witness, is perhaps the deepest wound and the greatest comfort. It places humanity within a vast, indifferent story, but it also connects us to that story's unfolding. The end of the Milky Way is not the end of beauty. It is the continuation of it, written in new forms across a changing sky. Philosophers once feared that science would strip meaning from the cosmos. Yet discoveries like this prove the opposite. That meaning expands as understanding deepens. To know that even galaxies die is to recognize the scale of creation itself, that everything born must change, that permanence is an illusion the universe never promised. For some, this knowledge inspired melancholy. For others, serenity. To gaze upon the stars, knowing their fate was not to despair, but to understand that existence, from a single life to an entire galaxy, is not measured by duration, but by the beauty of its transformation. And in that understanding lies the quiet reconciliation of science and soul. The Andromeda collision is not just a prediction, it is a meditation on impermanence. It reminds the species that built telescopes and theories that it too is part of this cosmic continuity. One day, humanity's light will fade. One day, even the Milky Way's name will be forgotten. But the atoms that once built human thought, the light that once illuminated our skies, will remain folded into new stars, new worlds, and new stories written in starlight. To know the fate of our galaxy, then, is not to fear it, but to recognize that nothing truly ends. The universe does not die, it evolves, and in that endless metamorphosis, humanity finds both its fragility and its belonging. For many astronomers, that belonging came with an unexpected weight, a realization that the act of observing the universe was no longer passive. To understand that the Milky Way is not eternal was to feel, in some quiet and ineffable way, the finitude of everything. They watched galaxies collide on screens in dimly lit rooms, the simulations unfolding like slow symphonies of light, and could not help but think of human history, of empires, cultures, and civilizations rising and merging, erasing and becoming something new. The same forces that sculpt galaxies seem to echo in the stories of humanity itself. Some scientists describe the emotional dissonance that came with such knowledge. The data was cold, precise, and absolute numbers, describing trajectories, velocities, and gravitational curves. Yet the meaning was deeply human. The realization that the sky itself was impermanent stirred something almost spiritual, a feeling rarely spoken aloud in the language of science. For centuries, the stars had represented constancy, the eternal backdrop against which life unfolded. But now, even that backdrop was revealed as transient, moving, colliding, reshaping, evolving in private moments, beneath observatory domes or in silent laboratories. Some astronomers confessed that this truth brought them a strange peace. To witness impermanence on such a scale was to feel liberated from the illusion of permanence in smaller things. If galaxies could merge and continue, then perhaps all endings, were not truly losses, but transformations. The public, when told of the coming collision, often reacted with awe, but also with unease. The word collision summoned visions of destruction, of cataclysm. Yet the reality was subtler, an event so vast that from the vantage point of a human life, It would unfold slower than any heartbeat, longer than any memory. The galaxies would pass through each other like ghosts, their stars rarely touching, their forms reshaped by gravity's slow hand. It challenged the human definition of catastrophe. What is an ending that takes billions of years to complete? What is destruction when no flame, no explosion, no sound accompanies it? Only the silent reorganization of stars. The universe, it seemed, practiced a kind of serene patience, a rhythm too slow for fear. Philosophers saw in this a reflection of humanity's deepest paradox, the desire for permanence in a universe that allows none. Across generations, cultures have built myths of eternity, heavens, afterlives, immortal gods, yet the cosmos, in its truth, offers no such sanctuary. It offers instead continuity, an unbroken thread of matter and energy reshaping itself endlessly. In the Andromeda Milky Way merger, this truth takes on form. The galaxies will not end. Their names will fade, but their stars will live on, drifting into new constellations, birthing new worlds, forging new elements in the hearts of dying suns. The same atoms that compose every living thing on Earth will one day flow through that vast, merged galaxy, scattered across light years, but still connected by origin. Perhaps that is the quiet lesson hidden within this discovery, that immortality exists not in the endurance of forms, but in the persistence of essence. The universe does not cling to identity. It allows itself to change. Humanity, in understanding this, confronts its own reflection, the need to let go, to see beauty in impermanence, to find meaning in the temporary dot in the end. The conflict of discovery was not between fear and knowledge, but between two visions of existence. One saw the future merger as a death, the erasure of what is known. The other saw it as an affirmation that from every collapse comes creation, from every silence a new song. Both, in their way, were true, and so the astronomers kept observing, not to prevent or change the future, but to witness it, to record the unfolding of a story written long before life began. Each measurement, each simulation, each photon caught in a telescope's mirror became part of a human act older than science itself, the act of understanding. For, in the end, the knowledge that even the Milky Way will vanish does not diminish wonder. It magnifies it. The awareness of transience sharpens beauty. The knowledge of endings deepens love for the moment. Humanity gazes at the stars, not despite their impact, but because of it, because in their slow motion toward transformation, the universe speaks the same truth, whispered by all living things, that to exist, even briefly, is a miracle vast enough. In the late decades of the 20th century, a quiet revolution began to unfold in the glowing light of cathode screens. Computers primitive by modern standards became windows into the deep future of the cosmos. Astronomers, armed with equations and imagination, attempted something no human had ever seen, to make time itself visible. They sought to simulate the coming collision between the Milky Way and Andromeda, to witness the fate of two galaxies locked in a gravitational embrace millions of years in the making. The earliest models were fragile, almost naive. Data was scarce, computation limited, yet even with imperfect tools, the results were profound. On pixelated displays, galaxies collided in violent bursts of light, stars flung outward like sparks from a cosmic forge. To human eyes, it resembled chaos, the heavens collapsing into ruin. These simulations mirrored our own fears more than the universe's reality. They reflected an instinctive human lens. That collision must mean destruction, that endings must be violent. But amid this rising digital vision, voices like Carl Sagan's offered a gentler interpretation. Sagan saw galaxies not as isolated systems, but as living entities in a greater cosmic ecosystem, evolving, interacting, transforming. He imagined galactic collisions not as deaths, but as rebirths. In his words, the universe was not only stranger than we imagine, it is stranger than we can imagine. That strangeness, he believed, held a kind of grace, an unbroken cycle of dissolution and creation. Still, for years, the science struggled to catch up with the poetry. Early algorithms could not model the subtleties of gravity across hundreds of billions of stars. The vast, fluid motions of stellar halos and the soft exchange of dark matter remained hidden, reduced to crude approximations. Galaxies seemed to smash together rather than flow into one another. It was a vision painted in broad strokes, lacking the elegance that nature prefers. Then, as the 21st century dawned, a new generation of machines and minds redefined the possible. Supercomputers began tracing the trajectories of individual stars with exquisite precision. They revealed what the early pioneers could not, that galactic collisions are not apocalyptic wrecks, but choreographed ballets of unimaginable scale. Stars do not crash into one another. They pass through vast gulfs of empty space, pulled and reshaped by invisible tides of gravity. What appears, from afar, as collision is, in truth, an intricate dance of light. Each simulation, refined through decades, peeled back another layer of misunderstanding. Astronomers began to see spiral arms stretch like ribbons, intertwining before merging into glowing rivers of starlight. The galaxy's black holes, once distant, solitary anchors spiraled toward one another in a slow, elegant orbit that would one day fuse their cores into one. From chaos, order emerged. From destruction, beauty. Observations from the Sloan Digital Sky Survey deepened this revelation. Across the universe, telescopes captured images of galaxies in various stages of collision, frozen snapshots of our own future. Some showed long tidal tails, streams of stars flung like silk into intergalactic night. Others had already merged into smooth, elliptical forms, luminous and ancient, their spiral patterns erased but their light undiminished. In them, astronomers recognized a prophecy, not of doom but of transformation. Each galactic pair became a mirror in time. In NGC 6240, two active black holes drifted ever closer within a single envelope of dust and gas, echoing what would one day happen between the Milky Way and Andromeda. In the antennae galaxies, vast nurseries of new stars flared into existence at the points of impact, proving that collisions could give birth as easily as they could destroy. The universe, it seemed, practiced renewal even in its grandest acts of upheaval. The narrative shifted. Humanity began to see the Andromeda Milky Way merger, not as a cosmic disaster, but as the next step in evolution. It was no longer the story of an ending, but of continuity, the blending of two stellar families into a single greater whole. A new elliptical galaxy, serene and radiant, would emerge billions of years hence, a testament to the universe's patience, and to the illusion of permanence that only time could dissolve. In the glow of these discoveries, a profound reflection began to form. The cosmos was not fragile. It was resilient, adaptive, alive in its own vast, unhurried rhythm. And as scientists watched the simulated galaxies merge and settle into new shapes, they realized they were not merely predicting the future. They were witnessing a truth older than humanity itself, creation and destruction. Order and chaos are not opposites in the universe. They are partners, inseparable and eternal. The galaxy's dance, slow, silent, infinite, is a reminder that every ending is also the beginning of another form of light dot. As the models grew more refined, humanity's window into the future widened. What once appeared as a blur of collapsing stars now unfolded with quiet precision, every orbit traced, every gravitational whisper accounted for. The Andromeda Milky Way collision no longer existed as a myth or distant speculation. It became a sequence of observable inevitabilities. Supercomputers across the world, from NASA's Ames Research Center to Germany's Max Planck Institute, recreated the event with staggering fidelity. Each run consumed months of computation, billions of data points representing stars, gas, and dark matter. And yet, within the mathematical silence, beauty emerged. The collision was not an instant, but a gradual merging stretched over billions of years. The two galaxies would meet, separate, and meet again. A slow gravitational waltz, each pass drawing them closer until they became one. Astronomers began to understand that Andromeda's arrival would not darken the night sky in chaos, but transform it into something sublime. Millions of years before the final merge, the sky of Earth, if Earth still existed, would shimmer with a view no human could ever see. The faint smudge of Andromeda would swell into a vast spiral looming across the heavens, filling half the sky with rivers of stars. Its core would glow brighter than any moon, and the constellations humanity once knew would dissolve into an unfamiliar, living tapestry. Even as the scene carried a quiet melancholy, it also held transcendence. For all their fragility, stars endure beyond the fleeting measure of species and civilizations. They would not shatter or collide in flame. Instead, they would drift, rearranging into new constellations of possibility. In the space between them, new stars would be born, children of both galaxies, fusing the histories of each into a single shared lineage of light. These realizations shifted the philosophy of cosmic observation. The language of science, once focused on prediction and control, found itself bordering on poetry. Astronomers began to speak of destiny, of renewal, of the universe's quiet intelligence. The collision became a metaphor not for death, but for transformation through connection. And in a strange, almost human way, the galaxies themselves seemed to reflect something timeless, that all structures, no matter how grand, must eventually evolve beyond their original form. The Sloan Digital Sky Survey continued to find examples of this cosmic metamorphosis, scattered across the deep sky. In pairs like NGC 2207 and IC 2163, the same patterns appeared: distortion, interaction, renewal. Stellar nurseries blossomed where gravity compressed gas clouds into luminous knots. Supernova flared briefly, scattering heavier elements, the seeds of future planets, into surrounding space. Life, it seemed, would not end with collision. It would only be rearranged into new potential, and beneath the scientific awe lay a humbler truth that humanity, bound to one small planet, had reached a point in history where it could not only witness the universe's past, but foresee its distant future. To predict the meeting of galaxies across millions of light years was not merely a triumph of mathematics, it was a statement of cosmic belonging. The same physics that governed the birth of suns and the death of worlds was written into every atom of the human body. In that realization, the Andromeda collision ceased to be a foreign event, detached and abstract. It became personal, a reflection of the same processes that shape life itself: fusion and fragmentation, attraction and transformation, cycles of creation that echo from the smallest cells to the grandest galaxies. The more the data refined, the more scientists began to sense that the story of Andromeda was also the story of continuity, of how the universe never truly ends. It only changes form. Every light that fades gives rise to another. Every collision births a new horizon. And one day, when the Milky Way and Andromeda have fused into a single luminous heart, their stars, ancient, patient, and unbroken, will still shine, carrying the memory of all that came before. The early investigations that once sought destruction had in the end revealed grace. Through the lens of science, humanity had glimpsed something sacred, the quiet persistence of order hidden within apparent chaos. And as the simulations rendered their final frames, one truth lingered. Even as galaxies fall together, the universe itself continues to rise. In the laboratories of the present, humanity attempts to foresee the sky of the far future. What was once confined to the imagination of astronomers is now entrusted to supercomputers, immense engines of mathematics that stretch human thought across billions of years. Within their digital memory, gravity becomes paint, and galaxies become fluid, brushstrokes swirling in time. Through them, scientists attempt to simulate the next 4.5 billion years, the slow, inevitable dance between the Milky Way and Andromeda. No human will ever witness the event itself, yet, frame by frame, line by line of code, the universe unfolds again inside these machines. Each particle of dark matter, each drifting star, is assigned a position and a velocity. Gravity does the rest. The models run in silence, guided by Newton's equations, Einstein's curvature, and the subtle corrections of modern cosmology. What emerges is both familiar and incomprehensible. A ballet of chaos refined by physics so precise that one misplaced decimal could alter the fate of a galaxy. The simulations revealed that the Andromeda Milky Way encounter is not a single collision, but a series of encounters, gravitational embraces lasting millions of years. Their spiral arms will distort, unfurling into elongated streams of stars, tidal bridges linking them before they fuse into one luminous heart. But in this grand choreography, small uncertainties carry the weight of destiny. The faintest difference in velocity, less than a kilometer per second, could mean the difference between a glancing pass or a direct plunge. Dark matter, the invisible scaffolding of the cosmos, looms over these predictions like a silent composer. Each galaxy carries a halo of it, unseen, undetected, yet accounting for most of its mass. The shape of these halos, their density and distribution, will determine the final form of the merger. Some simulations suggest that dark matter's gentle pull will draw the galaxies together in a smooth, spiraling descent. Others predict turbulence, gravitational eddies that could fling stars outward into the abyss, tearing away fragments of starlight that will drift in solitude for eternity. Within these vast calculations lies a more intimate question: the fate of the Sun. According to the most precise models, our star will endure. It will not collide, nor burn out by that time, but its path through space will be forever changed. The Sun will be drawn into a new orbit, perhaps thousands of light years from where the Earth once was. If any remnant of the solar system remains, it may find itself circling through the outskirts of the new merged galaxy, a cosmic exile, beneath unfamiliar constellations. Yet not all predictions grant such mercy. Some show the solar system flung into intergalactic darkness, ejected by gravitational tides too vast to resist. There, beyond the reach of any galaxy's light, it would drift endlessly through the cold void, its faint warmth fading into nothingness. A small, wandering island of memory, carrying the ghosts of a planet that once looked up and wondered how the heavens would end, and still, even this fate is uncertain. For nearby, another presence lurks, the Triangulum Galaxy, the third member of our local group. Its gravitational field, subtle yet persistent, could alter everything. If it joins the collision, it may transform the merger into a triple encounter, reshaping the trajectory of billions of stars. If it remains at a distance, its influence may still tug gently on the cosmic tides, bending the final orbit of the new galactic core. Science, at this edge, becomes both precise and poetic, a language of probability stretched across unimaginable time. Astronomers can predict the epoch of collision to within a few 100 million years, but not its final form. The physics is known, yet the outcome remains veiled in chaos. The closer one peers into the details, the more the future blurs. A reminder that even in a universe governed by law, uncertainty is its heartbeat. And so, the simulations continue. Terabytes of data rendered, compared, refined. Each new generation of models sharpens the clarity of motion, but never eliminates doubt. The Andromeda collision stands as both a triumph of understanding and a mirror of limitation. Humanity has learned when the galaxies will meet, but not how the story will end. For in every calculation lies a paradox. The more we understand the mechanics of the universe, the more it reveals its refusal to be fully known. Beneath the cold precision of numbers, there is still mystery, vast, unsolved, and deeply human. And somewhere in that mystery, between what can be simulated and what must be imagined, the future of the Milky Way waits, suspended in the stillness of time, in the dim glow of observatory control rooms, where monitors display the slow pulse of galaxies rendered in digital light. The limits of prediction begin to show themselves. Even the most advanced simulations run across thousands of processors, spanning months of computation, cannot escape the butterfly effect that governs cosmic motion. One unseen variable, one fragment of mass adrift in the void, could rewrite the choreography of billions of stars. Astrophysicists often speak of these models not as visions of certainty, but as poems written in the language of probability. Each run offers a different verse, a slightly altered rhythm of collapse and renewal. Some show the galaxies approaching head-on, their cores merging in a luminous cascade of gravitational waves. Others portray a gentler encounter, a near miss that draws them into a centuries-long spiral before they finally settle into one immense elliptical form, a single quiescent giant in the night. The key lies not just in visible matter, but in the unseen gravity beneath it. Dark matter, elusive and silent, forms halos so vast that their edges extend far beyond the luminous spirals we see. These halos brush against one another long before the galaxies visibly meet, creating subtle ripples, precursors to the grand collision. Within those invisible tides, entire clusters of stars may already be shifting, their orbits ever so slightly altered by forces that will not fully manifest for billions of years. And still, amid this cosmic unfolding, the scale of human achievement stands as a quiet counterpoint. To model even a fraction of a galaxy's motion, scientists must track billions of particles, each representing vast regions of mass, evolving through gravity alone. They do so using supercomputers that occupy entire buildings, their cores humming through endless loops of numerical integration. Every frame of the simulation is a triumph of patience, physics distilled into art, time folded into light. The data emerging from these efforts paints a universe where violence and beauty coexist. When Andromeda's core begins to merge with ours, immense streams of stars will flow like rivers of fire across the dark. Black holes at the centers of both galaxies, one in Andromeda, one in the Milky Way, will spiral toward one another, their gravitational fields bending space-time into ripples that will echo across the cosmos. The final union of these two titans may release more energy than any event since the Big Bang. though most of it will pass silently through the vacuum, unseen by any living eye. Even the fate of our own night sky becomes part of this tapestry. For billions of years, the constellations have appeared immutable, fixed markers of human myth and time. Yet, as Andromeda approaches, they will distort. The familiar patterns of Orion, Cassiopeia, and Cygnus will dissolve, replaced by a panorama of shifting light. The night will no longer belong to the stars we know, but to an evolving vision, one that reflects the impermanence of everything once thought eternal. The uncertainty that lingers at the heart of these predictions is not failure, but revelation. It reminds science that the universe is not a closed equation, but an unfolding story, one that continues to surprise even its keenest observers. The Triangulum Galaxy, for instance, small yet gravitationally potent, may become the unexpected author of the final act. Its approach could delay the merger, accelerate it, or warp its symmetry entirely. In cosmic terms, it is a whisper that could change the ending of a song. As researchers refine their models, the awe deepens. Each new simulation brings the future into sharper relief, yet never fully into focus. What remains certain is the inevitability of union, to galaxies drawn together by gravity's patient hand. Everything else is fluid, mutable, unknowable. The sun's path, the survival of planets, the precise shape of the final galaxy, all suspended within the thin veil between mathematics and mystery. And in that uncertainty lies a reflection of our own existence. Humanity, like its galaxy, drifts through time under forces it can predict but not control. To simulate the fate of the Milky Way is to glimpse the edge of knowledge, a frontier where precision and wonder merge. The universe, after all, does not reveal its future to be solved, but to be witnessed. And somewhere within the hum of distant stars and the silent code of machines, the next chapter of cosmic history is already being written, one calculation at a time, in the quiet chambers of astrophysics, where the universe is reduced to equations and light curves. One vision stands above all others, the mainstream theory of the Great Merger, a theory that tells not of destruction, but of transformation. In this vision, the Milky Way and Andromeda do not crash like worlds colliding, but flow together, drawn by the slow gravity of inevitability. Their spirals, elegant, ancient, and wide as eternity, will stretch toward each other, their arms twisting like silk in a cosmic wind. The encounter begins gently. Across billions of light years, faint tidal forces reach out, stirring the halos of dark matter that envelop both galaxies. Invisible bridges form, delicate threads of gravity connecting them long before their stars ever touch. Then comes the first approach. Andromeda will fill the night sky, its spiral arms rising vast and luminous, a horizon of starlight tens of times larger than the moon. The Milky Way's own disk will shudder as gravitational tides pull at its edges, distorting its shape into a luminous wave. Gas clouds will compress under the pressure, igniting a final blaze of stellar birth. For a brief epoch, perhaps a few 100 million years, the galaxies will glow with renewed youth, their spiral arms flickering with the fire of newborn suns. But the beauty is fleeting. As they draw nearer, their orderly rotation dissolves. The spirals unravel, their symmetry undone by the gravitational embrace. The two galaxies will pass through one another, continue on, then fall back together again. A slow, rhythmic dance of collision and retreat that spans millions of centuries. Each pass distorts their forms further until the distinction between Milky Way and Andromeda ceases to matter. What remains is one swelling structure, immense, luminous, and serene. Scientists call it Milkamada, the child of two galaxies, a new elliptical giant born from their union. In simulations, its form is smooth and red, stripped of the spiral arms that once traced the paths of star formation. The great reservoirs of gas and dust, the raw material for new suns, will have been consumed or expelled. The new galaxy will age quietly, its light fading to the deeper hues of old stars, its brilliance soft and melancholy. Yet, in this vast merging, something extraordinary occurs. Almost every individual star survives. The reason lies in the profound emptiness of galaxies themselves. The space between stars is so immense that even when two galaxies collide, the chance of two stars physically striking one another is almost zero. They pass through like ghosts, their orbits perturbed but not destroyed. The true collisions occur not in matter, but in gravity, invisible, silent, and immeasurable except through motion. At the center of both galaxies, however, a different fate unfolds. The Milky Way's supermassive black hole, Sagittarius A*, and Andromeda's even larger core will spiral toward each other, bound by an irresistible attraction. Over millions of years, they will circle closer and closer, warping the fabric of space-time with every orbit. Then, in one final moment of convergence, they will merge a cataclysm of pure energy, releasing gravitational waves that ripple outward across the universe. It will be the most powerful event the local group has ever known, and yet no explosion, no flash of light will mark it. Only a tremor through space-time itself, a whisper in the darkness that could one day be heard by instruments drifting in the distant future. In the aftermath, Milky will settle into a tranquil form. Its structure, once a chaotic vortex of interacting arms, will become smooth, spheroidal, and quiet. Star formation will dwindle to almost nothing. The bright blue light of youth will fade into the softer red of aging suns. The new galaxy will shine gently in the darkness, its double core glowing like twin suns stitched together at the center of infinity. And what of the sky, then? If any observer exists, human or otherwise, they will witness a spectacle beyond imagining. The heavens will no longer display the scattered constellations known today, but an ocean of stars stretching from horizon to horizon. The heart of Milky will dominate the sky, vast, radiant, serene, a living mural of all that once was separate, now made whole for those hypothetical descendants of Earth. The collision will not be an end but an awakening, the final act in the story of their home galaxy. A reminder that even in destruction there is artistry. Even in endings, a kind of cosmic rebirth. The universe will not burn in rage when the Milky Way and Andromeda meet. It will exhale, slowly, gracefully, transforming to spirals of starlight into one luminous, eternal whole. A galaxy forged not by chaos, but by the quiet hand of gravity, fulfilling a promise written in motion since time began. As time stretches onward, not in years or millennia, but in epochs, Milky will drift into a quiet maturity. The once vibrant bands of starlight will soften into a uniform glow, each star tracing a slow orbit within a new gravitational harmony. The turbulence of collision will subside, leaving behind a tranquil giant suspended in the dark ocean of intergalactic space. Within its vastness, the echoes of the past will linger. Deep inside its halo, ancient globular clusters, survivors from both progenitor galaxies, will move like silent witnesses, each one carrying the fingerprints of a vanished spiral. The stars themselves, now intermingled beyond distinction, will form new cosmic families, distant suns born of different homes, united in a single gravitational destiny, astronomers of the far future. If any consciousness endures to gaze outward, will look upon the smooth, elliptical body of Milky and find it hard to imagine that it was once two galaxies, each adorned with swirling arms and clusters of newborn light. They may never know that long ago, an intelligent species once looked up from a small blue world and wondered what would become of its sky. The collision, by then, will be myth, an invisible event written only in the orbits of stars. Yet its traces will remain etched into the structure of space itself. In the deep core, the merged black hole will dominate, with a mass perhaps 10 times greater than Sagittarius A*. It will anchor the new galaxy's heart. Around it, stars will move at astonishing speeds, their trajectories curved by gravity so intense that even light bends in its presence. From time to time, it may flare to life, feeding on captured gas or wandering stars, releasing jets of high-energy radiation that pierce the dark like cosmic beacons. Further out, in the fading light of the halo, the relics of humanity's solar system may continue their long, uncertain drift. If the Sun survives, and models suggest it likely will, it will have changed. By the time the merger is complete, some 5 to 7 billion years from now, the Sun will have exhausted the hydrogen in its core and swollen into a red giant. Earth, if it still orbits nearby, will be little more than vapor, long consumed by its dying star. But Jupiter, Saturn, and the frozen worlds beyond may endure, orbiting a faint, cooling ember, a white dwarf cast adrift through the new galaxy's tides. Perhaps their orbits will have shifted, tugged by Andromeda's approach, thrown into eccentric paths far from where they began. Or perhaps, in a delicate twist of fate, the entire solar system will be exiled, flung out into the dark between galaxies, a lonely caravan of planets circling a fading sun. Such exile would not be death, but solitude, a small system wandering the eternal night, carrying within it the memory of a world that once dreamed of stars. And even that solitude may be part of a larger pattern, one that repeats across the cosmos. For Milky will not be the only galaxy born of such union. The universe itself is filled with colliding pairs, the antennae, the mice, the tadpole galaxies caught in the act of merging, each one a living record of creation through destruction. Through them, astronomers have glimpsed fragments of our own future, a reflection of what is to come, from the antennae's tangled arms to the sombrero's luminous core. The story is always the same. Chaos yields to beauty, disorder to structure, death to renewal. And so the theory of Milky is not merely a prediction of physics, but a meditation on time itself, a cosmic reassurance that the universe does not end in silence, but transforms in endless rhythm. In its vast cycles, galaxies collide and fade, but gravity remains, weaving the fragments into new patterns, sculpting new forms of light from the dust of the old. Perhaps that is the true lesson of the merger, that creation is not a single moment, but a continuum. That even as one era dies, another begins, unseen but inevitable, written into the geometry of the cosmos. In the end, Milky will not mark the death of the Milky Way or Andromeda, but the continuation of their story, reshaped by gravity, preserved in light, and carried forward into eternity. In the quiet periphery of accepted science, there exists a different kind of astronomy, one not satisfied with what is merely probable, but drawn to the edges of the possible. Here, speculation becomes its own form of exploration, and imagination, guided by mathematics, dares to question even the nature of cosmic destiny. As the Milky Way and Andromeda drift toward one another, most models agree on a direct collision. Yet not all minds are content with this certainty. Some suggest a near miss, a graceful encounter in which the galaxies spiral past rather than merge, their stars stretching into luminous streams that encircle one another like dancers forever caught in orbit. In this scenario, gravity performs a complex symphony. The two giants approach, tidal forces tearing their arms into ribbons of starlight. Then, instead of collapse, momentum carries them onward. Over billions of years, they oscillate back and forth, locked in a gravitational duet, until the cosmic friction of dark matter halos finally draws them together in a second, slower embrace. It is not a collision, but a courtship played out across eternity, and beyond these elegant possibilities lie even wilder predictions, those that bring the Triangulum Galaxy into the stage. Triangulum, the third great member of our local group, may not remain a distant observer. Some simulations, run on NASA's most powerful supercomputers, suggest it could intervene midway, drawn into the chaos of the merger, spiraling in to form a three-body dance. In such a scenario, gravity's choreography becomes unpredictable. One galaxy could be torn apart, its stars flung outward in arcs of light, while another might gain new companions, swelling in mass and brightness. Others could be cast adrift entirely, millions of solar systems hurled into the deep void between galaxies, exiled beyond the reach of any starlight. Their suns would continue to burn in isolation, surrounded only by the faint whisper of the cosmic background, a reminder of the light they once belonged to. To some theorists, this is not chaos, but opportunity, for within those ejected systems lies the possibility of survival. If life were to endure long enough, if civilizations were to master propulsion across the stars, then the approaching merger might not spell an end, but a passage. Advanced beings could migrate from unstable orbits to stable ones, navigating through the gravitational tides like sailors riding the waves of a cosmic ocean. The collision could become a journey, an exodus written in the language of astrophysics. Already, speculative frameworks like the Kardashev scale imagine civilizations capable of harnessing the energy of entire stars, even manipulating gravitational fields themselves. In such a distant future, perhaps the merging of galaxies would not be a threat to avoid, but a phenomenon to witness, a spectacle watched from afar by minds who have transcended planetary fate. And deeper still, there are those who peer into the nature of dark matter, the invisible framework upon which all galaxies hang. Some wonder whether the collision of two massive dark matter halos could trigger unknown interactions, perhaps releasing faint bursts of exotic particles or influencing the shape of space-time itself. Could such a merger ripple beyond visible matter, altering the cosmic web, the vast structure that binds the universe together? No evidence yet confirms it, but the question lingers like a quiet hum beneath every equation. At the farthest reaches of speculation lies an even more abstract frontier: quantum cosmology. If space-time carries information, if every atom encodes a record of its history, what happens when two galaxies merge? Do their informational identities blend like two currents in a single river? Or does something deeper occur, a rewriting of existence itself, where every particle redefines its role in a new cosmic whole? In this vision, a galactic merger becomes more than a gravitational event. It becomes a meditation on identity, continuity, and transformation. Two immense beings each, the sum of billions of stars, meet not to destroy, but to become something greater than either alone. And in that reflection lies an ancient human metaphor, from the union of galaxies to the merging of souls. The pattern repeats. Endings are never absolute. They are thresholds. Just as stars are born from the ashes of the ones that came before, so too may the collision of galaxies give rise to a deeper order unseen but eternal. Perhaps in the language of the universe, what humanity calls collision is only another word for creation. When the Milky Way and Andromeda finally meet, it may not be a cataclysm. It may be a rebirth, a slow, luminous reincarnation, written in the quiet grammar of gravity and witnessed by no one but the cosmos itself. Even within the precision of equations, there are places where science brushes against philosophy, where the boundaries between data and wonder begin to dissolve. Theories that orbit around the Andromeda-Milky Way collision do not merely ask how galaxies merge, but what it means for the universe to do so. For in the silence of space, every transformation invites interpretation. Some cosmologists imagine the merger as a form of galactic reincarnation. The Milky Way and Andromeda, ancient spirals born in the dawn of cosmic time, will shed their arms and emerge as a new, more mature structure, an elliptical titan. To them, this process mirrors the life cycles seen everywhere in nature. Stars that burn, collapse, and rise again from their remnants. Atoms that migrate from one form of life to another. The same laws that govern the death of a star govern the rebirth of galaxies. Nothing is truly lost, only rearranged, yet others reach even further into the language of metaphysics. They ask whether information, the fundamental code of existence, survives such a merger intact. Every atom, every photon, carries data, a record of position, energy, spin, and history. When two galaxies merge, billions of such records intertwine. The result may not be the obliteration of data, but its synthesis, a new informational pattern born from the overlap of countless prior states. If the universe is at its deepest level, an informational system, then perhaps galactic collisions are moments of rewriting, cosmic updates in the grand ledger of reality. The mystery deepens when considering the black holes at each galaxy's heart. These are not just massive objects. They are engines of information paradox. When they eventually spiral together, they will merge in a burst of gravitational waves, ripples in the very geometry of space-time. The data encoded in their event horizons, according to quantum theory, cannot vanish. It must be preserved, though no one yet knows how. Could the merging of these two singularities, each holding the story of billions of fallen stars, represent the universe's way of combining histories, a convergence not only of matter, but of memory itself? In that possibility lies a strange kind of poetry, that every collision is also an act of remembrance. Some fringe cosmologists extend this thought further still. They imagine that such grand mergers might not only reshape galaxies, but subtly influence the texture of the cosmic web, the vast lattice of dark matter that underpins the universe. When two massive dark halos interpenetrate, their gravitational waves and particle interactions could send subtle tremors through that network, altering the balance of attraction across millions of light years. If true, then every major galactic collision might ripple outward, setting off chain reactions that echo through the fabric of the cosmos, unseen but cumulative. A universe, alive with interconnected motion, responding to every dance of its parts. To those who think this way, the approaching union of the Milky Way and Andromeda is not merely a local event. It is a note in the grand symphony of cosmic evolution, one chord in an ongoing composition whose music spans billions of years. And yet, the more one peers into these ideas, the more human they feel. The question of survival, of transformation, of what endures when two great entities become one, it mirrors the questions that have haunted civilizations since the dawn of consciousness. When stars merge, when galaxies collide, when black holes consume, are these acts of destruction, or simply the universe remembering how to change. In the faint glow of distant collisions, galaxies entwined. Like luminous spirits in the darkness, the answer seems to whisper itself. There is no finality in such encounters, only continuation through form and light and time. Even when the last stars fade from the future, Milky Way and the skies of any surviving world fall dark, the gravity that drew these galaxies together will still echo in the structure of the cosmos. For nothing in the universe is ever truly lost. It is only transformed from spiral to sphere, from brightness to memory, from isolation to unity. And in that eternal process of merging, one might see reflected not the end of all things, but the quiet persistence of existence itself, across the silent corridors of the cosmos. The quest to understand the approaching union of the Milky Way and Andromeda continues, not through myth or prophecy, but through light itself. The James Webb Space Telescope, suspended in the cold void a million miles from Earth, peers backward through time, gathering the afterglow of collisions that occurred billions of years ago. Each image it captures of galaxies torn, twisted, reborn, is a window into the future of our own. Webb's infrared eyes penetrate the shrouds of cosmic dust, revealing the hidden anatomy of merging worlds, vast tidal bridges of gas, luminous knots of newborn stars, and the glowing embers of those that perished. In those patterns of chaos and order, scientists read the choreography of Andromeda's coming embrace. Yet the telescope's beauty is matched by the precision of its partner, Gaia, orbiting quietly around the sun. Gaia has become humanity's mapmaker of the heavens. With a sensitivity so fine it can detect the width of a human hair from 1,000 kilometers away. It measures the subtle drift of over 1 billion stars. These micromotions, imperceptible to any eye, revealed the gravitational whispers of entire galaxies. Over years of accumulation, Gaia's data has turned the static sky into a living, moving structure. And from that movement, scientists have refined the trajectory of Andromeda itself, narrowing the uncertainties, defining the angle of approach, tracing the future with mathematical grace. But prediction in a universe of infinite motion is never simple. Even the faint tug of a smaller companion, such as the Triangulum Galaxy, can bend destiny. To overcome this, astronomers turn to supercomputers, artificial minds capable of simulating billions of years of evolution in days. Each simulation begins the same way. 2 great spirals drifting through the black, their halos of dark matter overlapping, their stars moving as though bound by fate. But each variation, each adjustment to velocity, spin, or mass unfolds a different story. Some end in swift collision, some in slow absorption, others in elegant orbital dances spanning eons. Thousands of such models run endlessly, searching not for perfection, but probability. Within their code lies humanity's most intricate attempt to see beyond time itself. And still, observation remains the universe's greatest teacher. Across the deep sky, telescopes focus on the living laboratories of galactic mergers, cosmic mirrors reflecting what will one day become of us. The antennae galaxies, tangled in a luminous collision 60 million light-years away, display the vibrant chaos of early merger. Their spiral arms stretch like filaments of light, forming bridges where new stars ignite in furious bursts. In NGC 6240, twin supermassive black holes spiral toward each other, encased in clouds of heated gas and X-ray brilliance, an echo of what will happen when the Milky Way's and Andromeda's cores finally converge. Each of these distant theaters of transformation offers not just a glimpse of fate, but a reminder that creation and destruction are often indistinguishable at cosmic scales. Yet beneath the technical triumphs and numerical precision lies a question that science cannot easily quantify. What does it mean to belong to a galaxy that is destined to change? To exist in a universe where permanence is an illusion, and even the stars are transient. The Andromeda Milky Way merger is not a story of endings, but of inheritance, of the cosmos recycling itself into new forms. From this collision will rise Milkomeda, an elliptical giant of calm beauty, its spiral arms long dissolved, its core serene. The night skies of that future galaxy, seen from any surviving world, will shimmer not with fear, but with wonder. Modern science has come to see in this union not catastrophe, but continuity. Every observation, every simulation, every photon of ancient light points toward the same revelation, that in the grand design of existence, chaos is not disorder, it is transformation. The Milky Way's fate is not to vanish, but to evolve. And in that evolution, the universe continues its most profound tradition, turning the old into the new, the separate into the whole, the fleeting into the eternal. For even now, across the gulf of billions of years, the first notes of that future symphony have already begun. The galaxies are moving, the data is gathering, and through the patient eyes of science, humanity stands as witness, not to destruction, but to creation on the most cosmic of scales. In observatories scattered across the world, from the frozen peaks of the Atacama Desert to the quiet plains of New Mexico, the story continues to unfold in light. Massive arrays of radio dishes move in unison, tracking faint emissions from hydrogen clouds that span intergalactic space. These whispers of matter tell astronomers how the Milky Way's invisible halo of gas stretches outward, already brushing against Andromeda's own. It is not a future event, they realize, but a slow and ancient process already in motion. The first contact has begun, not through stars or planets, but through the unseen threads of gravity and gas that connect everything. Each new observation deepens the intimacy between humanity and the cosmos. As instruments grow more sensitive, they reveal the delicate structures of galactic anatomy, the faint arcs of dark matter, the turbulent streams of ionized gas, the gravitational scars of smaller galaxies long devoured. And in those findings lies a haunting recognition. The Milky Way and Andromeda have already consumed others before. Each carries the memory of ancient mergers, ghostly remnants orbiting like faint shells of light. The coming collision is not an anomaly, but part of a recurring cosmic pattern. Galaxies grow by union, by consuming and becoming. To understand such vast behavior, science relies on time itself as a lens. By observing galaxies at different distances, some billions of light years away, astronomers effectively look backward across cosmic epochs. They see the early universe when collisions were far more common, when galaxies were smaller and hungrier. JWST captures these ancient moments in breathtaking clarity. Newborn galaxies twisting together, flaring with starburst activity, their collisions shaping the cosmic web that still defines structure today. These distant events serve as time-lapse mirrors of our future, each a record of what is to come. Artificial intelligence has now joined the pursuit, trained on countless images of galactic interactions, identifying subtle dynamics the human eye might miss, faint asymmetries, gravitational wakes, the invisible signatures of dark matter drag. These neural models run across thousands of cosmic possibilities, finding statistical harmony between chaos and prediction. Through this union of machine and mind, the dance of galaxies becomes less of a mystery and more of a language that speaks not of inevitability, but of transformation. Still, The mystery deepens when scientists consider the role of dark matter, the silent sculptor of cosmic destiny. Both the Milky Way and Andromeda are wrapped in vast halos of it, invisible but massive enough to outweigh all their stars combined. It is within these halos that the first gravitational contact occurred. Their invisible boundaries overlapped long before their luminous centers will, linking the two galaxies in a slow gravitational embrace. The dark matter determines the tempo, pulling the spirals together, guiding every future orbit and collision. Though unseen, it is the architect of fate in recent years. Gravitational wave detectors, like LIGO and Virgo, have begun to listen for the faint ripples that might echo from merging black holes, precursors to what will happen when the supermassive hearts of our galaxies finally coalesce. One day, perhaps billions of years from now, such an event will produce a burst of gravitational energy strong enough to ripple through the entire Andromeda Galaxy. A silent shiver of space-time that tells of two cores becoming one. The universe, indifferent yet beautiful, will mark the moment not with light, but with a tremor in its very fabric. The deeper scientists peer, the more profound the story becomes. What began as a prediction of motion has become a meditation on cosmic continuity. The instruments, Webb, Gaia, LIGO, the radio arrays, are no longer just tools of measurement. They are instruments of memory, capturing the unfolding of a cosmic truth that galaxies are not fixed monuments in space, but living entities in perpetual transformation. The Milky Way's fate, once feared as an ending, now reads like a promise that even in destruction, the universe creates something grander. Through data, light, and gravity, humanity witnesses not a death, but the next act in an endless cosmic play. And though the stage may shift, and the actors may dissolve into new forms, the performance, the song of creation itself, continues, unbroken. Through the silence of eternity, across the immensity of the cosmos, time moves differently. It does not rush, nor pause, it unfolds, like breath. Stars are born, drift, and die in rhythms so vast they escape human intuition. And within that slow pulse, a realization emerges. Humanity is not standing beneath the universe, but within it. Every atom of every body, every glimmer of thought, every fleeting life, all are chapters written in the same cosmic manuscript. For generations, the stars were seen as fixed, cold, unchanging beacons of permanence. But the truth, now revealed through centuries of observation, is far more intimate. The sky is not still, it flows. Every star is moving, every galaxy drifting, every beam of light a message from the past. The Milky Way and Andromeda are not silent sculptures in the dark. They are travelers, drawn together by the invisible thread of gravity. Their meeting is not a catastrophe, but a continuation. In this convergence, there lies a mirror for existence itself. For what is life but a series of collisions, of cells, of choices, of moments and meanings, each merging into something larger, more complete. Just as galaxies collide to form new worlds, human lives converge to form legacies, families, civilizations. The universe, it seems, repeats its own pattern at every scale. Creation through union, transformation through loss. Scientists call the process inevitable, a billion-year dance, already written in the math of motion. But inevitability does not mean futility. The knowledge of what will come does not diminish wonder, it deepens it. Knowing that the sky above will one day shimmer with the light of two galaxies, entwined, makes every glance upward a gesture of connection across time. In that awareness, humanity finds both humility and meaning. The understanding that even in the vastness we are not separate from the story, but integral to it. Some philosophers describe the future Milky Galaxy as a cosmic metaphor, the merging of two identities into one. It raises a quiet question. When boundaries dissolve, what remains? Does individuality vanish, or does it evolve into something greater? Perhaps consciousness itself follows the same principle, not destroyed when joined, but expanded, becoming something that memory alone could never contain. And beyond science, beyond prediction, lies something deeply poetic. The merging of galaxies is not an act of destruction, but of reconciliation. A slow, luminous embrace written in starlight, when the Milky Way and Andromeda finally unite. Their cores will spiral around each other like dancers in slow motion, radiating arcs of light into the surrounding dark. New stars will ignite in the aftermath, born from the turbulence of their union. From chaos, creation; from loss, renewal. In that moment, though no human will witness it, the universe will perform an act both ancient and timeless. It will transform. And through that transformation, the meaning of existence will echo once again, that everything changes, and through change endures. The scientists who map this fate do not do so in despair, but in awe. They watch through telescopes that peer back billions of years, tracing collisions that already happened, studying the aftermath of cosmic unions that gave rise to new galaxies. In each image, they glimpse the future of their own, and in that reflection, they find beauty, not fear. Because the universe does not end with silence. It renews itself with every collision, every collapse, every flare of rebirth, and so the story closes as it began, not with finality, but with motion. The Milky Way and Andromeda, once distant spirals, separated by emptiness, will someday share one glowing heart. The light of their merger will ripple outward, a beacon across the cosmos. A reminder that even in the coldest reaches of space, something still dreams, still reaches for union. The night sky above Earth will one day fade, but in the far future, somewhere within the new Milky, other beings, shaped by time, by stars, by persistence, will look upward and see a sky reborn. To them, the light of our sun will be but a whisper, yet part of their story still, because the universe never forgets. It carries every spark forward, blending it into the great current of creation. The sky above us is not still. It moves, it breathes, it dreams. And in that dream, two galaxies drift toward each other, to meet not in violence, but in light. In the distant reaches of cosmic time, long after the memory of Earth has dissolved into dust, the slow ballet of Andromeda and the Milky Way will continue silent, graceful, and unstoppable. Their shapes will distort as gravity weaves invisible bridges between them, tidal streams of stars stretching like luminous ribbons across intergalactic space. Each stream is a trace of history, billions of suns drawn from their ancient homes, now wandering in new orbits under a changing sky. Astronomers believe that when this final convergence reaches its crescendo, the two spirals will no longer resemble the elegant disks we know today. Their arms, once distinct and ordered, will twist and tangle, glowing with bursts of newborn stars. Vast clouds of hydrogen, the raw breath of creation, will collapse under the shock of collision, igniting new stellar nurseries that shine brighter than any night sky humanity ever knew. The merger will not bring destruction, but a renewal written in fire. Yet within this spectacle lies a quieter truth, the intimate resilience of stars. Despite the grandeur of collision, almost none will touch. The distances between them are so vast that, even in chaos, there remains harmony. It is a lesson in scale, a cosmic reflection of balance amid turmoil. Galaxies may collide, but the stars themselves, and whatever worlds orbit them, will continue to move, untouched, through newly forged heavens. In the aftermath, the two galactic hearts will spiral toward one another. Their supermassive black holes, each millions of times the mass of the Sun, will circle in a gravitational duel. Over time, they will merge, releasing a burst of energy so immense that space-time itself will ripple. Those gravitational waves will travel through the universe like the faint sound of a drumbeat, carrying the echo of this cosmic union to distant galaxies. It will be the sound of creation continuing, a low note in the grand symphony of existence. When the merger settles, what remains will be something entirely new, a single vast elliptical galaxy. Its spiral arms will fade, replaced by a smoother, more luminous shape, filled with ancient stars glowing red and gold. Star formation will slow, then cease, as the last reserves of gas are spent. The galaxy will enter a quiet age, a calm after the storm, where what was once to now lives as one. If life still exists in some distant system, born from one of those new stars, its skies will be extraordinary. Above that world, the heavens will shimmer with the glow of twin galactic cores, two brilliant centers merged into one, radiating across the night like eternal suns. To those future beings, the story of the Milky Way and Andromeda will be unknowable, buried beneath epochs of change. And yet, in their atoms, the legacy will endure. For the elements that once formed Earth, the Sun, and every living creature will continue to exist, scattered, recycled, and reborn. Perhaps, in that far-flung future, another civilization will rise, gaze upward, and wonder at the beauty of their own sky. They will not know that what they see, that vast glowing expanse, was once the aftermath of two galaxies meeting in the dark. But the truth will remain. Creation never ends. It only changes form, and somewhere in the deep silence between the stars, the memory of what once was will still drift, a faint shimmer of light across the cosmic ocean, whispering the same timeless truth that the universe has spoken since its beginning, that from every ending, something new begins, that even the grandest collision is a kind of love to spirals meeting in the vastness to become one eternal light.